Good morning. This is the application video for the ChemoCentryx Stair for the AISC IDEAS² Awards application. And before we begin our presentation, I'd like to take the opportunity to let the team members introduce themselves.
My name is Nicholas Gate. I'm a licensed architect, was the project manager for the ChemoCentryx Stair project.
My name is Joey Liberman. I'm a vice president with KPW Structural Engineers, the Alistair Bryan company, and I was a project manager.
And I'm Vittorio Chirito, senior project manager for Trubeck Construction, and we were the general contractor on this project.
And I'm Michael Verkeyk with Wesco Ironworks. I was the project manager for the project as well. So we'll begin this morning, our presentation this morning, and Nicholas with DGA will be providing a overview of the architectural design of the project.
Thank you. DGA is an architectural firm based in Mountain View, California. And the heart of the project, this project, was a staircase that connected the 5th and 6th floors for our client, ChemoCentryx. The idea behind the staircase came early on as a double helix, which describes a DNA molecule structure. And we use this interconnecting space to be able to have the users of the building, the lab users, which are primarily on the 5th floor, and administration staff offices, which are on the 6th floor, have a central connecting space that was pleasing and was able to be a connection between the two different functions in the building. The DNA strand became more of a architectural element that then transformed into more of a structural element to be able to have a floating stair that connected the two floor spaces. There are many of these spaces that are located directly next to the stairs so that the staff can be able to come and enjoy the expression of the space. And it is lined with wood panels and is very welcoming to all users and visitors to ChemoCentryx. The next step after we had come up with the design was to coordinate the structural connections with our team members, KPW, and Joey will talk a little bit more about how they achieved this.
Thanks, Nicholas. So using the architect's vision for the stair of a double helix with a thin profile, we got to work on what that structure would look like. Our immediate concerns were how to support it seismically and ensure that floor vibrations would not be an issue. So we started by developing a SAP model to analyze the framing for code level forces, which included about 2.5 inches of interstory drift. Laterally, our approach was to fully fix the bottom of the stair at the 5th floor. From there, it extends up 1 story to a bridge that frames out of an opening in the 6th floor. The bridge is a rigid horizontal truss that cantilevers out from the opening and ties it in to the 6th floor. The resulting design included curved 1-inch thick, high strength 65 KSI plate stringers and 1/2 inch thick plate treads and risers, which acted as a diaphragm. For gravity support, the entire stair and bridge structure is hung from above with 1-inch diameter rods located at the inner and outer stringers. With our SAP model built, we worked with a vibration consultant to determine that the inherent frequency of the structure would be within acceptable limits. They also studied the interaction of the stair with vibrations that would be induced by a large air handler that sits directly over the stair up on the roof level. And we locally stiffened some of the roof elements to mitigate floor vibrations and also to support the structure for gravity loads. I'll now pass it off to Vittorio to talk about construction.
All right, thank you, Joey. Yeah, so there was a tremendous amount of coordination that went into making this stair a reality. A few of the maybe not so obvious things that we want to go ahead and highlight here are, one, this stair and this project were just one of many projects on the site for this. And so the timing for the delivery and getting the actual materials into the building had to be precise. And we fit a very small window in between the grading and the paving activities that were also going on site in this area where our crane was going to be set up for that. Also, that what involved with that was removing sections of the curtain wall of the building to actually get the materials into the space, along with a few extra trusses that I'll talk about in a second here. One of the other things was the actual opening for the stair itself. This was a new core and shell building, but the core and shell wasn't designed for the stair. The stair was part of a tenant fit out, and so creating that opening was also part of this fit out. One of the things that went involved with that was putting in a temporary shoring system on the underside of the structure to allow those new steel members on that underside of the level 5 deck to go in to create, or the level 6 deck, I'm sorry, to go in to create that opening for the new stair. And along with that, safety is always paramount in construction here. So we thought, how can we do this? What's going to make the most sense to keep everybody safe during this demo operation? So a few things that we did in that were, one, coordinating the area off below where the demo was going to be happening. The second that we did was we put up a temporary safety platform under the entire area so that any demo materials, if they were to drop low, they're just going to hit that platform rather than going down to the next level, bouncing out, and potentially injuring somebody. The second thing, that platform also created fall protection. So in addition to the other fall protection measures, it was right below the deck that was coming out, and just helped make sure that everybody was going home safe at the end of the day, which is always the goal. The last thing that really went into this was the finish that went above the stair. So once the stair's in, it's a great monument to have it in there. How are we going to finish everything above? So what we did was, I mentioned those trusses that were brought in at the time that the steel was. We brought those into place and we spanned over the entire stair area on level 6 and created what we call the dance floor that the other finished trade partners were able to utilize to finish off the ceiling and the mechanical and electrical pieces that were going up there as well. And this was just a completely sacrificial item that, at the end, the trusses got cut up into pieces and brought out the freight elevator as the curtain wall already had to be put back in by that time to allow the rest of the finishes for the fit out to be installed. And with that, Michael's going to talk to you guys a little bit more about some of the other challenges and solutions that the project was faced with.
Thanks, Vittorio. So from a steel construction standpoint, obviously some challenges that required process innovations and let me back that up, and some thinking outside the box and just a really good plan at the start of the project to ensure its success. So with that, we capitalized and utilized the existing core and shell BIM model, and we received all of that as-built information. Utilizing that, our detailer performed the detailing of the stair 100% in Tekla structures. In conjunction with that, Wesco sent our internal field controls team out with our Hilti Total Station to not only compare and verify the information in the core and shell documentation, but also to perform layout for the stair. And our partner, Albina Company, up in Oregon, was the bender for all of the rolled components for the plate stringers, the DNA double helix structure, and the rail, and utilized state-of-the-art equipment to perform that work. In conjunction with that, kind of hand in hand, or the reason to make sure that we capitalized on the most current and state-of-the-art processes was due to the fact that there were some challenges on the project. And so solutions were identified before the start of construction to ensure the project's success. That was involved the cohesion of the design team with our steel detailer and making sure that they interfaced together. Tight tolerance control during the fabrication and erection of the stair system. as I'd mentioned previously, utilizing all the information available at our fingertips, both as-built documentation and site survey results, utilizing Albina as our rolling partner, fitting up the stair, laying it out in our shop with a reflected ceiling plate layout on the shop floor, and then actually doing a dry fit of all the components prior to erection. So we assembled in our shop using 3-axis fixtures and rigging, and then disassembled and delivered to the site, and flew up with a crane to the 5th floor balcony, and then hand carted the stair components over into the final position. There are some photos of the fabrication process, starting with the plate rolling, the unitized components of the stair, the dry fit in the shop, the rail fit up, and then the rail finish welding. And then lastly, kind of a sequential order of photos of the erection of the DNA double helix component, the stair, the bridge across, and the railing, and the hanger rods. So as you can see, we're very proud as a team of not only the final product, but the steps that it took to ensure the project success. And we thank you very much for your time and consideration.